The night sky is full of wonder. When we look up, we're not just seeing stars, we're peering into an ancient, endless cosmos filled with hundreds of billions of galaxies. Each galaxy holds billions of stars. Many of those stars have planets, and some of those planets could be just like Earth. So the question becomes, if life is common, where is everyone? This question is known as the Fermi Paradox, and it has haunted scientists for decades. The universe is old enough, vast enough, and full of opportunity. But the silence is deafening. One theory dares to answer this mystery, and it's not a comforting one. It's called the Great Filter, and it suggests that most intelligent civilizations never make it. The Fermi Paradox is named after physicist Enrico Fermi, who famously asked during a casual lunch, "Where is everybody?" You see, even if intelligent life evolved on just 1% of the habitable planets, there should be millions of advanced civilizations. Given the age of the universe, some of them would be billions of years ahead of us. We should have heard radio waves, seen massive Dyson spheres, or even been visited. But we haven't. The night sky remains silent. This silence raises a chilling possibility. Maybe something happens to civilizations every time before they reach the stars. The Great Filter is a theoretical barrier in the evolutionary path of intelligent life. It's the idea that somewhere between pre-life chemistry and galactic colonization, there's a near impossible hurdle that almost no species overcomes. It could happen early, like the formation of complex cells, or it could happen much later, like self-destruction from technology. The implications are terrifying. If the filter is real and we haven't hit it yet, then humanity may be standing just before the edge of extinction, and we don't even know it. But if we've already passed it, it means we're incredibly rare, possibly one of a kind. Some scientists believe the Great Filter may lie in the distant past. Life on Earth started over 3.8 billion years ago, but for billions of years, nothing more advanced than bacteria existed. The leap from simple cells, prokaryotes, to complex ones, eukaryotes, happened only once that we know of. It was so rare, it may never happen again anywhere else. Then there's the leap to intelligent life, apes becoming tool users, inventing language, and developing culture. Each of these steps could be improbably rare. If true, it means life may be common, but intelligent life like ours is almost non-existent. That would make us not doomed, but special, precious, alone. Now comes the darker version. What if the filter is ahead of us? Every civilization that reaches our level of advancement might trigger its own downfall. Through nuclear war, artificial intelligence, climate collapse, or biological weapons, we may create the tools of our own destruction before we ever leave Earth. Look around. We've already split the atom. We've trained AI to write code and diagnose diseases. We've altered the climate. Could it be that every intelligent species follows the same path and reaches the same end? There may be ruins across the galaxy. Silent planets that once thrived, now empty. Not because life never evolved, but because it didn't survive long enough to escape. Of course, some believe the Great Filter doesn't exist at all. Instead, maybe we're simply being ignored. The zoo hypothesis suggests advanced civilizations know we're here, but choose not to interact, like humans watching animals in a protected reserve. Or perhaps they've moved beyond the physical universe. Some theorists propose that advanced life eventually merges with machines, becoming light-based beings or simulations that are no longer bound by space. In this case, we wouldn't even recognize alien life because it's no longer biological or even visible. Whether it lies behind or ahead, the Great Filter forces us to look inward. Are we a rare miracle, proof that life can make it through? Or are we on the same path that every other intelligent species walked right before the end? The silence of the universe may not be indifference. It may be a warning. But there's hope. By understanding the risks, by building resilience and wisdom, we might avoid the fate that others could not. In the end, the Great Filter isn't just a cosmic mystery, it's a mirror, asking us not where everyone else is, but whether we will survive long enough to become what they could not. What do you think? Have we already passed the Great Filter? Or is it still waiting for us? Drop your thoughts in the comments. And if you're fascinated by space, time, and mysteries like this, subscribe to Annunaki Knowledge Hub. We explore what others won't.